recorded. The presentation is normally 20 minutes and followed by sort of a, I don't know, 25-minute, half an hour question period. And you can put questions into the chat all the way along, and you can also raise your hand during the question period. And we're going to make the recording available, so you'll be able to review it if you'd like to. Now, has Matthew joined us?
Yeah, hello.
Matthew, you're there. That's excellent news. So let me introduce you properly. So as I said, Matthew also works at UCL at the Institute for Sustainable Resources, where he's been working on climate policy and the circular economy, especially on interactions between the environment and the economy, often using energy system and macroeconomic models. So his academic publications have been cited in the Intergovernmental Panel on Climate Change, WG3 AR6, by the UK Climate Change Committee, and he is an author on the Lancet Countdown on Health and Climate Change. He's part of the UK Energy Research Centre and was a member of the University College London COP26 delegation, and he's a member of UCL Commission on communicating climate science. So Matthew is involved in the NICER program as he's actually doing research as part of the Circular Metals Centre, and he's also supporting the research that's going on in our centre on macroeconomic modelling. And the other thing that you may be interested to know, and for your viewing pleasure later on, is that Matt is also a stand-up comedian who performs live climate change comedy at festivals and comedy clubs around the UK, and he hosts the BBC Radio 4 show Net Zero, A Very British Problem, and has a TEDx talk about the importance of using humour to discuss climate change, and has a book out. So without further ado, I will pass on to Matthew to give his talk.
Hi, everybody. Thanks for being with us this afternoon. Pleasure to come and chat to you. I'm not quite sure where everybody's backgrounds are and what projects everybody's on, so please do ask questions in the chat along the way, or have questions. You know, keep them for the end, and very happy to answer them. But yeah, so I work on the Circular Metals project, which is a kind of adjacent. There's 5 different circular economy centres, and we're actually involved. My team, so the team that I work in, sorry, is actually led by Alvaro Calzadilla, who I believe is on the call as well. So I'm not 100% sure, but he may be able to answer questions as well in this area. But Julia sort of invited me to just present because we'd sort of chatted through some of these methods very early before the project had even kicked off, and so she thought it would be good to kind of speak again about these methods and kind of help understand how these can be used, I guess, within the project. But yeah, so I work on the Circular Metals project as well, where we're looking at steel and aluminium. But the types of the approach that I'm talking about today, we use for various different issues, some around energy and climate issues, but I guess more recently around the circular economy over the last kind of 6-7 years. And yeah, we've sort of been trying to develop in that area, and so hopefully this is just a bit of an introduction to that. And how it might complement some of the other kind of approaches that are used in this area. So I will share my screen, I hope. And go from there. Everybody see that okay? I can only see Julia, so Julia's going to have to nod. Yeah, all good. So yeah, this is sort of an overview of sort of top-down macroeconomic approaches to the circular economy. And what does that mean? Well, it means that rather than looking at products and individual either technologies or materials. We look at it from the entire economy and trying to look from a very top-down approach as to how the circular economy or how different materials and metals and stuff like that fit into the overall economy. So we're always thinking at it from a very joined up perspective with every other part of the economy in mind, rather than focusing on material, specifics. So quickly try and show you how that works. So what we try and do is capture the entire economy, the flows of consumption and income in the economy, and so households earn income and then consume things. It flows to enterprises and back again. And it can become a bit more complicated when you add in savings and investment and how those work within the economy, and how taxes and public expenditure work, and where you've got imports and exports to the rest of the world. So what we're trying to do is capture this entire thing. And these types of models that we're talking about and the types of databases are used by, say, the Treasury to understand how will they what is the current state of the economy in the UK, for instance, although it could be any economy, and then the types of models that we employ, that they employ as well, could look at just changes in tax rates, whether that's domestic or changes in trade. Tariffs are obviously interesting as well. But what we're doing here is sort of applying that principle, which is in the middle, and situating it within environmental issues, and that's where we specialize in. But the Treasury, in the UK, does have a team as well that use models like this, that have some environmental components to it. But I think the main thing to stress, though, is that the database and the models are set up primarily to look at economic issues, and then the sort of environmental stuff has been added and tried to be included over time, rather than it being an approach that was initially set up to to consider environmental problems. So there are other approaches or other things that were perhaps set up more initially to look at environmental issues. So this is a bit more of a complicated diagram of that, of the flows that we're trying to get. But what I'm going to spend most of my time doing is actually kind of just showing you an actual practical example in a minute. So the main thing sort of behind these types of analysis are input, output, and social accounting matrices, which are roughly the same. They have a lot of similarities as social accounting matrices, just a little bit more complicated. It's a matrix essentially, so there's a bit more detail. The input output database is most of the same data, but just missing some stuff. And to just explain quickly what it is, basically it is a region. It can either be a national region. It could be a part of an economy, or it can be multi-regional. So there are global input output databases that have hundreds of countries. But I think it's easiest to start from the perspective of, say, just imagining the UK. So what you have then is a single year, a snapshot of all economic interactions at a very high level of within 1 year, and that includes all the sort of intermediate monetary flows, as well as the value added, so things like employment and capital expenditure, and then all of the sort of demand for the things that are produced in a single year. And again, the most important thing to stress there is probably that this is all in monetary data, as opposed to what a lot of people work in, where it's physical data. So we're not looking at flows of tons of steel. We're looking at flows of pounds of steel, essentially. And so you have different industries in the economy which can produce different goods, and the outputs of those goods can be sold to, are eventually purchased by either other companies. Everything in the economy either has to be purchased by other companies as inputs to things that they make, or it needs to be sold to households, government, or investment or exports. So that's kind of the main thinking, and these are used to, as I say, create different models, sort of more basic models like input, output, or SAM multipliers. But you can also have things like CGE models, which are a bit more complicated, or other types of models based on that, such as macroeconometric models. But all of these use roughly the same sort of databases. And this is sort of how it looks. I'll give you a more specific example in a second, but this is how it looks more generally. So you have a transaction matrix here in the middle, and all of those sales to intermediate demand there on the left-hand side, and then sales to final demand and total output. So you're sort of reading across the way, but you can also read it down the way. So you have purchases, value added, and total input, and basically your inputs have to equal your outputs. And then what we try to do is add environmental extensions on there, and that can be more complicated when you've got lots of different countries. So you know, 3 countries here potentially, and you need to capture the domestic data for each country, as well as imports from one country to another, and that sort of thing. So this is a very starting with a very basic example that I've used of Scotland in 2004. So in terms of, I'll probably try and spend most of the time just explaining this, and then going into a bit more detail of a more complicated one. But basically, you're looking at 3 sectors of the economy. So the economy has been aggregated up to 3 whole sectors. So you know, there's a lot. You can look at it in a lot more detail, but here you've got primary and construction, you've got manufacturing and utilities, and you've got distribution, transport, and services. And that's the whole economy in terms of all of the industries that you could possibly have. And what you're doing is, if you're able to sort of look, read across the way, so the numbers in that top row are, actually, let's read down the way first. So let's look at the first column. So the primary and construction sector, these are the first 3 numbers there are the inputs to that primary and construction. So if you want to make a unit of output of this industry, you need 3,513 whatever it is, £1 million, I think we've got here, of itself. But you also need an input of manufacturing and utilities, and you need an input from the distribution, transport, and services sector. And then you also keep looking down. So that's the total intermediate. So that's all of the inputs that you need to produce a unit of other intermediate inputs. But then you have imports, you have taxes, net of subsidies, you have compensation of employees, so labor essentially as what you're going to produce, and other value added, which is often considered as sort of the capital expenditure, you know, what you actually need in terms of buildings and machinery and stuff like that. And that then gives you the total output, the total input of that sector. So the total inputs are 18,907 there, and you'll notice that matches with the total gross output on the top right hand corner as well. So when you read across the way of that top row, you're reading the primary and construction. Well, where does sales of that sector in that year go? Well, it sells a certain amount, the top left hand corner, 3,513, to itself, but then it also sells it to manufacturing utilities, it sells it to other industries there, but then it also sells 10,000 to final demand, of which some will be households, some will be governments purchasing these things. And so that's kind of a very simple way of reading it. And so you have all these sort of intermediate, that top left box essentially is all the intermediate transactions within the economy. How do industries make things essentially? And what do they need from other industries to be able to make their products and transfer that on? So I'll give it, and I'll go into a bit more detail of us on a spreadsheet in a second. But essentially, what you can then do is try to create a model based on this, where you look at, well, what happens if demand increases for one of those sectors? What if there's going to be an extra 10% of demand for construction going forward. Well, how's that going to affect the rest of the economy? And so what you can do quite basically is make assumptions about, well, that assuming that's some sort of exogenous demand change, then we can calculate something called the inverse matrix, and how that change in demand would then lead to different multipliers throughout the rest of the economy. So it's not 10% increase doesn't lead to just a 10% increase in the economy, because you need more intermediate inputs and so on and so on. And so we can make some assumptions here, sort of unconstrained supply side demand. So the supply in the economy is able to increase to meet that demand. And also the very simple assumption here, which is a bit limiting, is sort of you have a Leontief technology. So you've got the idea that the inputs to make one unit of output is fixed, although you could change that. And so in terms of yeah, so you've got sort of different multipliers that you can calculate, and you can add environmental extensions onto that as well. I mean, I don't know if it's necessary to go into the detail of this, but basically you can calculate, use some matrix multiplication to create this basic model, where you sort of get a solution, and you can understand, well, if you get an increase in the vector of final demand, so if there's an increase in demand by households or government purchases of construction, are going to increase by 10%, then that allows you to calculate what the impact will be on the rest of the economy. So let me quickly bring up this table. So here's an example. Did I do this one? Yeah, let's try this. Here's an example for Scotland in 2004. So if we zoom out here, you can see that there's a table of all these interactions for about 123 sectors in that year, as well as then your taxes, basically labour, compensation of employees and operating surplus. And I've highlighted here just in yellow what I think, for instance, for construction, what sort of sectors you would need to be looking at. So you would probably look at, you have at this point in time 4 mining sectors, one of coal and peat extraction, one of basically petroleum, oil and gas, one of mining of metal ores, and one of other mining and quarrying.
Can you zoom in a bit, Matthew?
Yeah, sorry. Yeah, let's go in a little bit more. So, this is, I'm just going to try and show you the linkages through the supply chain here a little bit. So that would be one sector. And so you can understand, well, what are the inputs from other sectors into that sector of mining and quarrying? But again, we don't have the detail here to specify, there isn't mining of, whatever it is, limestone isn't specified as a sector. It's all, you have to look at what's sort of included within that sector. And if we look further along, which will kind of be along the supply chain a little bit, you would have other things, another sector like bricks, tiles, construction products, baked in clay. You've got a sector that's cement, lime and plaster. And then you've got another sector that's let me bring this down a little bit, articles of concrete, plaster and cement. So it's sort of like things that have been produced and off probably in this previous sector and then sold on, that are a bit more finished. And then further along again, elsewhere in the economy, you have a construction sector, for instance. But we've got everything here. So every sector of the economy is here. You've got, aircraft and spacecraft, furniture, lots of things. So, we have to take all of this into consideration together. And then you can look at, well, what's the inputs to construction? What are the main, where does construction buy most of its stuff from? So actually, so what I did was I had a quick look at another version of this for 2019, so the most recent one, and it's a bit slightly different. So this is for Scotland as well, and it's not quite the same aggregation of sectors, but you've got cement, lime and plaster as a sector, you've got glass, clay and stone, and you've got construction, and the mining sectors are a little different. But if you look at, for instance, what goes into construction, so I've just looked at what are the inputs of different sectors for construction there compared to the total output of that sector. So the whole of the construction sector, what are the different inputs? And if you look through it, which ones are sort of fairly large, you've got, I guess, wood and wood products is, I've just highlighted what are the top 10 inputs here. So wood and wood products are 1.1% in a monetary, so I'm sure these are different in physical values, but for monetary values, you've got cement, lime and plaster is about 1%, clay, glass and stones a little bit less. You've got metals are about 1%, and then you look further down, so construction, 20% of the input into the construction industry is itself, so that'll be construction companies sending money to other parts of the construction industry. So these numbers where it's sort of self purchases can be often are quite large and quite difficult, and that shows why it's quite detailed, quite difficult when you don't have more detail about the sectors to be able to look at it. But you also have things like wholesale excluding vehicles is about 1% or so, and then you look further down, unsurprisingly, architectural services, etc., are about 1% of the construction sector's inputs, and you then have larger numbers further down. Essentially, unsurprisingly, you have 14% are imports from the rest of the UK to Scotland, about 6% from the rest of the world, and then you have employment constitutes about 23% of the spending of the construction sector, and about 20% there is capital as well. So that gives you an idea of, at a very aggregated level, of what the inputs are to the construction sector. And if you look at, well, where do some of these things go? For instance, the cement, lime and plaster sector. So if we look a lot across the way now, you can see that I'm just highlighting, well, where's the big sales essentially from cement, lime and plaster? Where do they sell most of their products to? So they sell some to the oil and gas industry, but I think the largest one by quite a long way, and they sell some to themselves. But you can see here about 46% of sales of cement, lime and plaster go directly to the construction industry, which is going to be the largest one, I think, by quite a bit. Because if you look along the way, yeah, everything else is fairly small, and then you have some, again, this is Scotland, so some is exported to the rest of the UK, about 20% is exported. So this is just kind of looking at the table in a little bit more detail and trying to understand what the inputs and outputs are of this. And so what we can do is then we can say, well, what happens if there's an increase in demand for construction of exogenous increase of demand by 10%? What does that do to the rest of the economy? And it'll be a much larger kind of multiplier effect. So I'll quickly show you the last table. So this was an analysis. It's not about construction or anything, but it's stuff that I'd done before. So you can aggregate these tables together depending on what it is you're interested in looking, what sectors you're interested in looking at. So I've aggregated it to, I think, about 25 sectors here from 123, and then I've added sort of emissions related to those sectors as well. So CO2 emissions per £1 million of output. You add these sort of coefficients to it, and then we can calculate these multiplier effects. So let me just have a look at, let's find, there must be the cement one here just to give us an example. Clay, cement, lime and plaster is M. So this number here would suggest that for a 10% increase in exogenous demand, in the demand for clay, lime and cement, you would get, so if it was a 10% increase, you'd get a 17.8% increase in overall economic activity in the UK. Yeah, I think this was the UK, but whatever the region is. So basically it's saying that the multiplier, you have 10% increase, but the overall economic impact's then going to be not quite double, but it's not far off it. And so different sectors will have sort of these different multiplier effects depending on how much they're linked to the other parts of the domestic economy and what inputs you need for them. And then you can look at how that might relate to emissions. So if you have an increase in CO2 of a certain amount, I can't remember exactly what this is. I think that would refer to the tons. Yeah, so 7 for an extra increase of 1 output of 1 million, you would have an extra 7,704 tons of CO2. So there's a lot more that I could go into here, but I realize we're already kind of getting to the end. There's different types of models that we look at, so we can extend this database to make it a social accounting matrix and kind of look at all the different actors. So you've got different activities, commodities, factors, households. These are all sort of actors in the world, and they all have their own different area. And then you can extend it to CGE model as well. Now, very quickly, what did we do for this in the steel industry? Well, we've done a couple of things. One thing is we've basically added detail to those sectors. So, for instance, if I quickly show you, sorry, here, if there's the iron and steel sector, is casting of metals. Basic iron and steel. Okay, so iron and steel is a sector in the economy. But what we've done is just one sector, essentially. So what we've done is globally, we've taken 150 odd countries, and we split that sector into 2 to try to add more detail. And specifically, the detail we've added is sort of primary and secondary production of iron and steel. So we've included recycling within the database, and then we're able to actually model what happens if we switch production from primary to secondary, and we've tried to add detail on scrap availability and stuff like that. So that's what we did in one of these papers, and we tried to look at, well, what happens to China when a lot more scrap comes online, scrap steel comes online over the next kind of few decades, and what are the kind of economic impacts of increased scrap use in China. So we had different scenarios, and we looked at, well, then, for instance, the types of analysis we can say is, well, there's a positive impact in certain cases on China of using more domestic scrap because it's now importing less iron ore, and there's a negative impact on countries like Australia and other parts of developing Asia and Brazil who would normally import iron ore to China to be used, given that China produces like half of the world's steel. So we can say, well, there's GDP impacts on these countries, and also changes in steel prices, changes in outputs across the different sectors, these different sectors in the economy. So what sectors can use more scrap steel, and what are the different changes in the inputs, the sectors which would normally input into steel production. So there's a lot of stuff we can talk about, and we've also tried to look at, well, what happens to the sectors in the supply chain that use steel and how much secondary steel can they use. So the construction industry here, for instance, on the right hand side, uses a lot of scrap, and we can look specifically at, well, how much more scrap steel could be used in China and the different scenarios that we're looking at. So sorry that's it's kind of a very quick run through some stuff, but hopefully it's reasonably interesting. And yeah, hopefully we've got about 15 minutes for questions. Yeah, hopefully that's enough time and we can chat a little bit. If I stop sharing, yeah, thanks.
Thanks very much, Matt. So if I'm just checking whether we have anything in the chat. I don't see any questions. Oh, wait. So strangely, I seem to have a chat from a previous session.
Yeah, I can see the latest question. Do you want me to read it out?
Yes, please do,
yeah.
Because I can't see anything in the chat from today.
Yeah, so Rebecca Hooper has asked, fascinating, how do you account for uncertainty in the outputs? Mute, Matthew.
Yeah.
Apologies. There's sort of two ways of looking at it. I mean, the data we're using is, you know, actual data that's already there, and we would try to look at it as an individual, you know, standalone change to one aspect of the economy. So often people are thinking, well, what's going to happen to the economy? But there's millions of different things happening in lots of different parts of the economy, and there's no way you can try to capture all of that. So what we're trying to do is we're trying to isolate here, if this was to happen by itself, you know, with no other changes, what would, given the current state of the economy, assuming that the economy, the structure of it doesn't change, what would the impact therefore be? And therefore, I don't think there is, if you're looking at it from that perspective and not looking kind of forward in time, there isn't necessarily any uncertainty in outputs there. But as soon as you start introducing equations and you start looking forward and you start trying to make assumptions about, well, what's going to happen, you know, those are the more interesting questions. What's going to happen in you know 50 years time? Yeah, there's massive uncertainties around what's the structure of the economy going to be, what sort of growth rates are you going to have, what are the parameters that you've decided upon. And so a lot of what happens sort of beyond that, when we start trying to use CGE, computable general equilibrium modeling of this, is we allow for substitution. So in the very simple input-output analysis, you have sort of things are produced how they're produced today, and that's it. There's no changes. And you also don't have any kind of inclusion of prices there. But what happens when you add slightly more complex models is you get you make some sort of a change, you know, some sort of exogenous shock, and then you have changes in relative prices that allows substitution between different products, so you can try to produce things a bit differently than you produced them before. And so we would try to parameterize a lot of those things, and you know, how much substitution is possible of certain you know, production of certain goods. And there, yeah, there's massive amounts of uncertainty. So, I mean, we try to calculate sort of sensitivity analysis around those things, and yeah, kind of go into a bit more detail about sort of what the key parameters are. But kind of going forward, I think things are going to change around this modeling. I know Alvaro has done some analysis previously with other colleagues that have used sort of AI to be able to run the model, you know, 1 million odd times, and therefore really look at what the uncertainty is by running the model so many times. And I think that's probably what's the kind of the direction of travel of this. But yeah, it's there is there is a consideration of uncertainty, but often it does get quite it's kind of the modeler's choice of you know, you have to interpret where you know, and understand where are the real uncertainties and try to dig a bit behind that and try to do some analysis on that and pull it out. So yeah, most papers do have a bit, whether it's an appendix or whether it's in the results about what are the key parameters in terms of uncertainty.
Thank you. Lily has got her hand up. Lily, if you want to go ahead.
Yeah, thank you. Really fascinating to hear about this work. And so I work at the Department for Energy Security and Net Zero, and I can see lots of applications for this kind of modelling, and indeed some of our existing assumptions that are based on these sorts of models. But one big, I guess, evidence gap that we have is definitely around how sort of global supply chain movements might change the outlook for our overall economy and future, and particularly that analysis you presented on China sounds really interesting. I was wondering if you'd done a similar thing from a UK perspective of looking at what would happen if domestic scrap were recycled in the UK.
I'm glad you've asked that question, because we actually just presented some work a couple of weeks ago that was very kind of initial about that. In fact, Alvaro's, I can see he's joined in, he's eager to, he presented the work, so I'll let him talk about it. But that's exactly what we were thinking about. We're trying to think, if the UK moves to more domestic scrap recycling. So the UK currently exports about 3/4 of its scrap steel. It's got a massive resource there that's unused essentially, and I think undervalued. But obviously there's sort of difficulties around that, electricity prices and other things that would require, to do more recycling. But yeah, Alvaro, if you want to jump in just now, but it's absolutely something we're thinking about.
Yes, and thank you very much. Indeed, this is the type of analysis that we are doing for circular metals. And basically, as Matthew mentioned, we know that we have enough scrap that we are exporting this. So the main question that we wanted to ask in that paper was, what are the economic implications if we use the electric arc furnace at full capacity, and how much scrap we are going to use for that? And basically, then we know that there is still a capacity which is unused for electric arc furnace, and we basically set up scenarios in order to increase the use of scrap up to the full capacity of these electric arc furnaces. And basically, we also explore the impact of different instruments, economic instruments, to make that possible. So we explore, for example, subsidies to secondary steel production. We explore also taxes to primary production, taxes to the imports of iron ore, and also we play with subsidies to electricity used by secondary production. And then we saw the different impacts, and actually the main result of the analysis was the subsidies was the most appropriated policy instrument to reach to that objective. And of course, we did this analysis just looking to 2050, because we know that if we want to use more of the scrap which is available in the UK, we will need to increase the capacity of electric arc furnaces. And of course, this can be also assessed in one of these models, but what we need is to include all the investment in order to do that. So we need to increase basically the capacity of electric arc furnace, and this means a huge investments in infrastructure. And we haven't done that yet, but this is one of the things that we are going to assess with the model, as well as with alternative technologies, more advanced technologies in the steel industry, like, for example, explore hydrogen-based steel production and also CCUS in the steel industry. Yeah, sorry, just wanted to mention that.
I just want to say quickly to make the link between this work on electric arc furnaces and the work that's going on at Cambridge on Cambridge electric cement. Cyril is there, so just not to comment any further right now, but maybe you guys can get in contact, because I think it's all very relevant to each other.
That's very kind of you to make the link. Yes, I'm always happy to chat, because we're looking at co-production, so I don't know how to deal with it in your matrix.
I think that could get quite complicated, but it sounds really good.
I think we have some more questions in the chat.
Sorry to say to Lily, before, in case she has to go, we're planning on having a workshop over the next coming months around this with stakeholders as well. So it'd be great if you were interested to come along to that, and anyone else that would like to come along as well. Sorry, Ramya.
Yes, so the question in the chat is unconnected to ICEC MCM, but with parallels. I have a private sector tier 1 contractor who wants to do an R&D project to look at a regenerative twin of a large school they built in South Wales, creating an alternative design proposal that is net positive in carbon that uses locally sourced materials. Would your model be able to quantify the impact on the local economy in this context?
That's a good question. Yes. So I mean, South Wales is a fascinating area for stuff like this. You would probably need, I mean, you would need the data set for Wales, which I think the Welsh government might have. I know the Scottish government have been really big on creating their own databases. I'm not 100% sure about the Welsh government. There has been tables like this for Wales in the past, but I'm not sure quite how up to date they are. But I don't think there would necessarily be a snapshot of South Wales or whatever the region specifically. But yeah, in essence, if you did have that data set, you could absolutely quantify those sorts of economic impacts on it. So yeah, it's probably more of a data issue than anything else.
Thank you.
Sorry, can I just say, I see that we're approaching the end of the time. I think there are lots of questions, and if Matt is willing to stay to take them, then I think we should try and discuss those things, and we'll continue the recordings. So thank you very much to those of you who have attended and are unable to stay. And you can catch up with the recording later. And just to say, we're not having an August webinar, but there will be September and October ones. So just keep looking out in our regular channels, and we'll let you know the topics and details for those. Right, let's carry on with the questions then.
Okay, I'll just cover the other 2 questions in the chat and then go on to Nick, who's got his hand up. So the next question is, if our goal is to expand our recycling capacity of materials, it is crucial to assess whether the upcycling industry is capable of sustaining the increased demand. How resilient and scalable is the industry in meeting the growing recycling needs?
Yeah, I mean, an absolutely fundamental question there. I mean, I have been looking at it for steel, but it's something that for other materials really needs to be looked at in a lot of detail. And actually, that's why the sort of linkages with industry on these projects are so important, to be able to get ideas of how scalable would this be. Often it's downstream capacity. So even if there is recycling capacity, is there demand for those products downstream, or is there demand for, is there enough capacity to add sort of extra rolling and processing, for instance, with the steel industry? So yeah, it's really, our bit is very high level, and we try to take information from it elsewhere on whether there is those possibilities about essentially expanding industries and increased capacity. But it's really, yeah, it's absolutely crucial, I think, is what I would say. And you kind of have to look at it on a material or industry by industry basis, and really start to work more with those people that are doing the recycling, and their understanding of the capacity needs. But yeah, I mean, it's fundamental, that question.
The next one is, could this model be used to look at mineral demand from infrastructure or housing projects and policies, and then cross-check against in the mineral reserves available through current planning?
Yeah, I mean, that's again something that could potentially be, done. Yeah, I guess you're talking about demand from infrastructure. Sort of the higher level it is, the better. So if you're able to look at really large, UK-wide infrastructure or housing projects, and then look at the reserves available. But I mean, you then have to have, when we look at reserves, I guess it's when you say against the mineral reserves available through current planning. I mean, global reserves, I guess, is what, you know, what percentage could be met domestically and what would have to be imported, I think, is what you would then come up with as a sort of result of it. But yeah, I think absolutely that you could do that for this. It's maybe a little bit simplistic in the, again, we're looking at monetary flows and how you attach physical amounts, you know, efficiency improvements of mineral use and other things like that. You have to be able to try and include them in here as well, which, you know, some of the models we do try to do, but again, we're not necessarily experts in, you know, efficiency improvements and stuff like that. So we have to speak to others to kind of get an understanding of how that might change in the future. But yeah, it's absolutely, Rebecca, that's exactly the type of question you'd want to look at here.
Nick,
Okay.
do you want to go next? And then there's a couple of questions on the workshop, I believe. So.
Thank you. Yeah, thanks for your time. Very interesting to hear about what you're doing. I just have a sort of geeky question, really, about the sort of how you handled within sector purchases. So for steel and construction, you often see there's quite a high value that the steel sector sells or purchases from itself.
Yeah.
And it's almost like the same product, the value goes to like, you know, like the crude steel goes to a finisher or a re-roller or something like that. Effectively, it's kind of like the same product.
Yeah.
And the full value of that product sort of almost inflates the within sector purchases. So we've had a bit of, so I'm from Department of Energy Security and Net Zero, and we often sort of wonder how to treat the sort of the within sector purchases. Sometimes we exclude it because of that sort of inflating factor. But I just sort of wondered whether you'd sort of treated it in a special way.
No, it's a really good point, and often, yeah, when you come across a sector that has a lot of that, it can be really hard to say, as you say, anything meaningful about it. And the only way around it I can see is to become more granular with those sectors, and try to understand, well, how can you break that out further? And again, that depends on the question you're asking, but you know, we obviously have the with the steel, we've done, you know, primary and secondary production, and there does tend to be a kind of, you know, rolling and processing sector as well, and you kind of tend to be able to at least see those flows, but you know, it's still the same number, but it's just split over 3 cells as opposed to all within 1 cell. But I guess that's where the conversations with industry are really important to understand, well, what's real, you know, what's the real value here? Where's, you know, where are those transactions actually happening within the sector? And maybe having, you know, sector specific databases would be really useful to actually try and break them out. It's kind of something I'm interested in, and I have been writing on a little bit. Is like, well, if we want to do net zero properly, especially for some sectors, there's just no detail there. So what data do we need? You know, what data sets do we actually need to make it feasible to be able to analyze any of this sort of stuff? You know, and I think construction would be one, but you know, I think the motor vehicle sector is another large one that I've looked at, that just needs far more granularity, and that probably needs a bit of a push. I don't know whether that is going to be, you know, the ONS collecting that, or whether it's more likely, you know, it's not going to be at that level, but you're going to have to, you know, we're going to have to set up projects that actually spend time delving into really key sectors to just understand the, you know, the flows and the data behind them. I don't think there's any other way around it, if you know what I mean. So yeah, it's something that yeah, if using this approach, and that's where, you know, the more granular approaches of LCA and that sort of stuff can come into their own a bit more, where you've got like lots of products and trying to merge the more bottom-up approaches with stuff like this. So we've got a PhD student that's looking at the global aluminium industry, and she's got a background in MFA, so material flow analysis, and we're trying to combine that with CG analysis so that there's a bit more of a, you know, there's the more granular detail from the bottom up, but then you're going to have to make assumptions about how they join with the economic data. But you're probably going to be able to say a bit more about, you know, those sort of intersector stuff in there. But yeah, it's really hard.
Yeah, it's worth feeding back to ONS if it's you know, if there are sort of improvements in that line, and that they don't often, I don't think that they sort of the input output tables, supply use tables have not always been the most sort of regularly produced. So
no. But we sort of need, I mean, my idea is that we sort of need a project that's, well, how would you design this if you're interested in solving net zero? You know, what data would you need from, rather than taking what's already there, you know, what would we actually need if we were going to kind of start from scratch and try to develop a table, you know, that had the right data in it.
Thanks, that's very interesting.
Good to hear from you, Nick.
Julia, you're on mute.
Oh.
Julia, you're on mute.
Yeah, no, but it's okay. Yeah, so I just want to say we are going to have to stop at 2 because we have another meeting to go to. And so we may be able to take another question or two, but just for the moment, I also wanted to make everyone aware that we do actually have a macroeconomic modeling project as part of our mineral-based construction material center, and that fellow will be looking for a placement of something like 6 months or a year. So if any of you are interested in having more of this kind of approach implemented in your organization, then the person to talk to about that is Alvaro. Alvaro, can you just say a couple of words about the work that Metin is doing? I don't think Metin is on the call, but if you could just say a few words, then.
Yes. Yeah, sure. Thank you very much. Yeah, we have a postdoc working full time on this project. He is on holiday, so he was unable to join this time. But he is basically creating a multi-regional CG model for the UK. This means that the UK is going to be split into 12 regions. So we are going to have even a greater detail in terms of supply chains and production activities within the UK. And for the moment, we are creating this model as a standard one. So using the data which is available, which is basically similar to what Matthew has shown. But then the next step is to include and to have more detail on the cement and the construction industry. So the plan is, for example, to try to represent green cement and green concrete, and to see how, using one of these approaches that Matthew showed, what are going to be the impacts on the economy. But because we do have a multi-regional model, we are going to see the impacts also at the regional level and at the household level, because those are the details that we want to capture with the construction of that model. And the model is still in progress. So I think early next year, we will have some preliminary results in order to show them. I'm going to be very happy also to explore different scenarios within the cement or the steel industry.
Thank you, Alvaro. Okay, so maybe is there time for one more question? Is there one more question?
Yeah. There are only two. One's very quick. Is the workshop specifically related to steel, or is it more general?
So that workshop is going to be on the steel paper that Alvaro talked about, so specifically on steel. But I imagine once we're a bit further down the line with the project, as Alvaro was talking about, then I imagine probably sometime next year there'd be a workshop more specifically on the results that we get out of construction minerals.
Thank you. And then one, sorry, go on.
No, that's fine. It's more to get the right stakeholders, you know, steel specific people in the room to understand what are the specifics of the steel industry, and then, you know, move on and try and look at. So it's more kind of industry by industry. It's easier to kind of look at it that way. That's why.
And then the last question is a question/comment. Do you speak with the UK Steel at all? And also government is not into subsidies, regrettably, so need is to find market answers. And then DEFRA used to link at minerals needs in planning and link to resources, but this ceased in about 2012, and the industry had to gather the data.
Yeah, I mean, yeah, I saw that comment. Yeah, UK Steel. I actually spoke to them a bit on a different project recently, so we do have some contacts there, and I will get them along to the workshop, hopefully. And it's that, but it's a tricky balance between getting you really need it, industry input on this, absolutely, but you also don't want them to completely define the types of scenarios and the feasibility of stuff. It's kind of a bit of both. But yeah, we'll definitely be working with them. And yeah, on the subsidies aspect, I think it's kind of, what we tried to do is just show a range of different possibilities. So, you can have different taxes, you can have subsidies, but also, what we'll probably need to look at a bit more is things like the carbon border adjustment mechanism that's going to come into place, and trying to be modeling that. But yeah, and then you can look at funding, government spending on R&D subsidies and stuff like that for this sector. But as much as governments don't like, I mean, I don't know. I wouldn't say they don't necessarily like subsidies. I mean, the contracts for difference for offshore wind is very much a subsidy, and it's been massively successful. So I think if it's done correctly, as long as it's not just if it's well designed subsidies, I think it's possible.
I think that's it. That's all the questions we had, and that brings us pretty much to the end of our time. Over to you, Julia, if you want to say anything.
Yeah, no, just thanks for your participation and the interesting questions and the great answers. And we look forward to further interaction in this space. So yes, thanks, and see you next time, hopefully. Bye-bye.